The recording survives on a spool of magnetic wire sealed in a classified archive for 50 years. What it holds isn't testimony so much as an ending. Listen closely. There is the rhythmic wash of ocean static, the mechanical hum of a propeller, and then a sudden, violent crunch, an explosion followed by the groan of steel twisting under pressure. On the wire, it is the instant the boat is open to the sea. This fragment is the closest thing to a witness for the final seconds of the Imperial Japanese Navy submarine I-52. She vanished from the surface of the mid-Atlantic overnight on June 23 into June 24, 1944, taking about 112 people aboard, including Japanese crew and passengers plus 3 Germans, into the dark. The I-52 was not a standard attack boat. She was one of Japan's big Type C-3 cargo submarines, a massive underwater freighter stretching 356 feet from bow to stern. Her mission fell under Yanagi, long-range exchange runs meant to keep the Axis connected after Allied control of the surface oceans cut their routes apart. Germany had radar, jet engines, and optical technology Japan needed. Japan had raw materials the German war machine was starving for, so the trade moved underwater halfway around the world through hostile waters. The I-52 departed Singapore with a manifest that read like industrial desperation made physical. Her holds were packed with strategic metals, molybdenum, tungsten, and tin, along with crude rubber. She carried opium and quinine for the German pharmaceutical industry, and the payment for the technology waiting in Lorient, France, rode in small metal boxes, 146 bars of gold bullion. It was a ransom an empire under siege was willing to pay. On the night of the interception, the I-52 surfaced 850 miles west of the Cape Verde Islands. She was there to rendezvous with a German U-boat, U-530, carrying radar equipment, including a detector, and German specialists meant to help shepherd the Japanese boat through the Bay of Biscay. The transfer was successful. 2 German radar technicians and their gear, along with a navigator, went aboard I-52, and the massive Japanese submarine turned north. She did not know that the Allies were reading her radio traffic. An American hunter-killer group led by the escort carrier USS Bogue was closing the net. At nearly midnight, a TBF Avenger aircraft flown by Lieutenant Commander Jesse Taylor picked up a radar contact. The I-52 was running on the surface, charging her batteries in the heavy darkness. Taylor attacked immediately, dropping flares that illuminated the giant submarine before she crash-dived. The water closed over the conning tower, and the I-52 disappeared from sight. In a conventional war, she might have escaped. A submerged submarine is invisible to radar and difficult to track by sonar in the rough Atlantic. But the rules of engagement had changed. The American aircraft dropped a pattern of sonobuoys, floating microphones that transmitted underwater sounds back to the plane and its recorder. Then it released a new and secret weapon, the Mark 24 Fido, an acoustic homing torpedo built to hunt by listening for submarine machinery and propeller noise. The sonobuoy wire recorded the sequence. The hum of the I-52 propellers is clear. Then, the distinct high-pitched whine of the Fido torpedo enters the soundscape. The 2 sounds merge. There is a loud detonation followed by the groan of tearing metal and the chaotic noise of a vessel breaking apart. After the explosion, the wire recorded only silence. The I-52 was gone. The gold, the rubber, the tungsten, and the crew were removed from history in a single violent instant. The surface did not offer a clean, cinematic confirmation, but searchers did find scattered debris and oil drifting near the attack, including sheets of raw rubber among the flotsam. For 5 decades, the final resting place of the gold shipment remained a coordinate on a map that led nowhere. The resting place of the I-52 is defined by a single vertical measurement, about 17,200 feet, roughly 5,240 meters. To understand the scale of this abyss, one must look at the most famous wreck in history. The Titanic lies at 12,500 feet. The Japanese submarine is nearly a mile deeper than that. At this extreme depth, the Atlantic Ocean is a crushing, lightless void, with water pressure climbing into the range of 7,000 to 8,000 pounds per square inch, enough to punish ordinary machinery and turn search into survival engineering. The physics of the ocean determined the fate of the submarine long before it hit the bottom. When the Mark 24 Fido entered the water in 1944, it relied on passive acoustic homing. It did not ping, it listened for propeller and machinery noise from a submarine trying to run. Cavitation could add its own hiss and throb to that signature, but the weapon's genius was simpler. Follow what it could hear. The resulting explosion breached the pressure hull, and gravity finished the work. The I-52 began a 3-mile descent. With her pressure boundary breached and compartments flooding, she fell through the water column toward 17,000 feet of dark. What the sonobuoy wire preserves is the first violence, the blast, then the groan of stressed steel. Not a full certified verdict on exactly how the hull failed. Whether sections gave way on the way down or on impact, the aftermath would be written in physics. Heavy components tending to fall tight, lighter pieces more likely to spread with the currents and the seabed's terrain. Finding this debris field required overcoming a phenomenon that once fooled sonar operators for years. It is called the deep scattering layer. This is a false bottom created by biology, not geology. Countless marine organisms, especially fish with swim bladders, along with squid and jellyfish, migrate vertically through the water column each day to avoid predators. They can form a dense, living cloud typically a few hundred meters down, hanging far above the true seabed. To a surface ship using early sonar, the deep, scattering layer can throw back an echo that feels like bottom. Solid enough to be believed, deep enough to mislead. It isn't a seafloor thousands of feet wrong, but a convincing false return at exactly the moment weather, currents, and wartime navigation errors are already stacking the deck. In this region, it helped mask what lay beneath. Rugged, mountainous topography. The target area was not a flat plain. It was a chaotic landscape of underwater ridges and volcanic rock that looked identical to a twisted submarine hull on a sonar screen. To distinguish the gold from the geology, a search team would need to penetrate the scattering layer and map the bottom with a resolution that did not exist during the Second World War. The I-52 lay in the cold zone, protected by the physics of sound and the sheer weight of the ocean, waiting for technology to catch up to the difficulty of the depth. The coordinates recorded in 1944 were a lie, created not by deception but by the chaos of war. When the researchers opened the archives 50 years later, they found a fundamental contradiction. The pilots of the USS Bogue reported sinking the Japanese submarine at one specific latitude and longitude. The German U-boat commander, who had just transferred radar gear and specialists to I-52, recorded the rendezvous point more than 10 miles away. In the open Atlantic, a 10-plus mile error is the difference between a successful salvage and a futile search in the abyss. To find the wreck, the investigation required a forensic re-navigation of the entire engagement. The research team analyzed the drift of the sonobuoys, the wind speed on that night in June, and the Avenger's flight time. They realized the I-52 had run north after the rendezvous, charging batteries on the surface before the attack began. When they set the German log beside the American attack data, the search box jumped, well outside the area where the Navy assumed the submarine had gone down. Verifying this calculation required a technology capable of seeing through the total darkness of the deep ocean. The tool selected was side-scan sonar. Unlike the active ping of a surface ship, which punches through the water column vertically, side-scan sonar is a towed sensor. It is housed in a streamlined metal torpedo called a towfish, which is dragged behind a research vessel on a steel cable several miles long. The physics of this instrument are precise. The towfish flies just a few hundred feet above the ocean floor, emitting fan-shaped pulses of high-frequency sound to the left and right. These pulses strike the seabed and bounce back. A hard object, like the steel pressure hull of a submarine, reflects the sound energy with high intensity, standing out on the display, sometimes as a bright return, sometimes as a dark one, depending on the palette. Behind the object, where the sound waves are blocked, there is an acoustic shadow. By measuring the length of that shadow and the geometry of the ping, operators can reconstruct the height and shape of the object. In 1995, the search team deployed the system from a Russian research vessel, the Yuzhmorgeologia. The operation was a slow, methodical mowing of the lawn. The ship crept along at low towing speed to keep the towfish stable so far below, while miles of armored cable bowed through the water in a long catenary. If the ship turned too sharply, the sensor could swing wide, or worse, clip the ridges and seamounts hidden in the dark. Day after day, the monitors showed only the geologic noise of the Atlantic floor. Then, the sensor painted a distinct anomaly. It was not a rock formation. The return showed a long, linear object sitting upright in the sediment. The dimensions were unmistakable. The acoustic shadow measured approximately 356 feet, the exact length of a Type C3 cargo submarine. The target was mostly intact. The sonar image suggested the hull was sitting on its keel, not upside down or shattered into unrecognizable fragments. This was a critical piece of forensic evidence. It implied that the I-52 had flooded quickly enough to equalize the pressure, or that the break was clean. The debris field was scattered around the main hull, a confetti of heavy metal that had rained down through the water column. The math of the re-navigation had been correct. The ghost position contained a ghost ship. But a sonar image is only a reflection of sound. It could confirm the wreck's shape, not confirm what the wreck still held. The debris field down there is not a random junkyard. It is a geometry trap. When a submarine breaks apart under extreme pressure, the ocean floor becomes a maze of jagged steel, torn cabling, and unstable overhangs. Navigating this environment requires a pilot to think in 3 dimensions while trapped inside a titanium sphere. In 1998, the expedition returned to the Atlantic with the Russian Mir submersibles. These deep-diving vehicles were among the few machines on Earth capable of reaching the bottom of the I-52 site. They were not there to scan shadows, they were there to make visual contact with the crime scene. The descent to the bottom took hours. As the Mir submersibles drifted down through the water column, they passed through the zone of total darkness. When they finally leveled off just above the sediment, their external lights cut through the gloom to reveal the wreck. The I-52 was sitting upright on the seabed, exactly as the side-scan sonar had predicted. The hull was largely intact, but the damage told the story of the final seconds. The pilots maneuvered the submersibles around the conning tower, inspecting the steel for the signature of the kill. Expedition accounts describe major damage aft of the conning tower. A jagged breach consistent with the detonation of an acoustic homing torpedo, such as the Mark 24 Fido. The surrounding plating was curled and torn, the kind of violence you expect when an external blast compromises a pressure boundary. It matched the broad outline of the 1944 attack reports, a sudden detonation, then silence. Exactly what failed inside the engineering spaces can only be inferred, but the wreck carried the unmistakable signature of a kill. But the mission was not just to inspect the damage, it was to find the cargo. The research team knew that the gold bullion was stored in the commander's cabin, which was located forward of the control room. If the submarine had broken apart during the descent, the gold would not necessarily be inside the hull. It would be scattered in the sediment. This search relied on a concept known as debris field geometry. When a vessel disintegrates underwater, the ocean acts as a massive sorting machine. Objects fall according to their density and their shape. This is called hydrodynamic sorting. Heavy, compact items like engines, batteries, and gold bars plummet straight down. They fall fast and land close to the point of breakup. Lighter, wider objects like hull plating, deck grating, and personal effects have a high drag coefficient. They flutter and drift in the current, landing hundreds or even thousands of feet away from the heavy debris. The pilots of the Mir submersibles used this logic to narrow their search. They ignored the distant plating and focused on the area immediately surrounding the main break in the hull. If the 49 boxes of gold had spilled out, they would be sitting in the mud near the heaviest sections of the wreck. The search was slow and dangerous. The submersibles had to hover inches above the silt, avoiding the snag hazards of torn netting and sharp metal that could trap the vehicle on the bottom forever. The lights swept back and forth across the gray sediment. The pilots were looking for the specific rectangular shape of the metal containers described in the manifest. The margin for error was 0. A single wrong thruster input could slam the delicate viewports into a steel girder or stir up a cloud of silt that would blind the cameras for hours. Then, amidst the chaos of the wreck site, the geometry resolved into a recognizable form. Lying in the debris field, partially buried in the sediment, was a rectangular object, not structural steel, but a manufactured container. The manipulator reached out and clamped on. The pilot secured the artifact in the collection basket. I-52 had finally surrendered a piece of its cargo. The ascent from 17,200 feet is a slow vertical journey through increasing light and decreasing pressure. For the crew, the metal box in the external basket was more than a salvage trophy. It was the potential validation of the entire expedition. The object matched the kind of containers described in accounts of I-52's cargo. The team believed they had recovered the first fraction of the gold. On the swaying deck, the box was inspected. Corrosion had fused the lid shut. Engineers used heavy tools to pry it open. Inside were tightly packed, brick-shaped bundles wrapped in protective material. But when the wrapping was cut away, the dull yellow gleam never came. As later reported in the press, the box held opium, one of the medicinals carried on the voyage, not gold. This discovery was a shock, but it was historically consistent. The I-52 was a blockade runner carrying strategic raw materials. In 1944, Japan controlled the poppy fields of occupied China and Southeast Asia. The German military machine had a desperate need for morphine and other opiate-based painkillers for its field hospitals. The opium was just another commodity in the war effort, packed alongside the tungsten and the rubber. It was a trade good, valuable in its own right, but it was not the bullion that had justified the cost of the recovery mission. The presence of the opium box in the debris field presented a cruel paradox. By the team's own debris field logic, a lighter cargo should have wandered farther from the main break. Instead, it was close, an uncomfortable clue that whatever happened on the way down may not have followed the clean, sorted pattern they expected. The fact that the opium was found near the main hull section suggested that the I-52 might have held together longer than the acoustic analysis predicted. It implied that the breakup happened closer to the bottom, spilling the contents in a chaotic heap rather than a sorted field. The gold was likely there, perhaps only a few yards away from where the submersible had grappled the opium box. But it was not sitting on the surface of the mud. The density of the gold meant it would have punched through the sediment layer, burying itself beneath the silt, or perhaps it lay trapped under the crushing weight of the fallen engine section. The opium recovery still mattered. It proved the manifest was accurate, and it proved the cargo containers could survive the fall. But it also proved the Atlantic does not give up its valuables easily. If the bullion had spilled, it wasn't sitting neatly on the surface of the mud. It was buried, pinned, or hiding somewhere inside the wreck's three-dimensional puzzle. And the gold stayed down. The 2.2 tons of gold bullion remain on the bottom of the Atlantic. In the deep ocean, proximity is not possession. The expedition proved that the I-52 lies exactly where the physics of the engagement said it should be. The debris field contains the shattered remains of the hull, the scattered raw materials of the Yanagi mission, and the silent evidence of the 112 men who died in 1944. The forensic investigation solved the mystery of the disappearance, even if it failed to recover the primary treasure. The acoustic recording on the Gordon wire was validated by the visual inspection of the wreck. The tear in the pressure hull matches the sound of the explosion. The recovery of the opium box confirmed the manifest was real. The I-52 was indeed carrying the strategic wealth of an empire, and it was destroyed by the first generation of smart weapons. The Mark 24 Fido torpedo changed the nature of naval warfare, proving that a machine could hunt a submarine by sound alone. The wreck is the physical proof of that technological threshold. The question of the gold remains the final paradox of the site. The leading theory is a matter of simple geology. The sediment at this depth is soft, a thick layer of microscopic shells and silt that has accumulated for millions of years. When the submarine broke apart, the heavy objects fell with tremendous kinetic energy. The gold bars, being small and incredibly dense, would have acted like kinetic penetrators. They likely did not stop at the surface of the mud. They punched through it, burying themselves deep in the substrate, invisible to cameras and sonar. Alternatively, the gold may be trapped beneath the largest remaining sections of the submarine. The diesel engines and the electric motors are massive, solid blocks of steel. If the gold storage locker collapsed under them during the breakup, the bullion is now shielded by tons of immovable wreckage. To recover it would require heavy industrial excavation at a depth where most machines implode instantly. The cost of such an operation would likely exceed the value of the metal itself. The gold is safe, protected by the very physics that make the deep ocean so hostile to human ambition. Before the mere submersibles left the site for the final time, the crew performed one last act of closure. They did not leave a claim marker or a salvage buoy. Some accounts describe a small memorial gesture at the wreck, a respectful marker, an ensign, something meant for the dead rather than the ledger, honoring the sailors who perished in the darkness. I-52 is no longer just a target on a sonar screen or a line item in a treasure hunter's ledger. It is a war grave. The Yanagi mission was a desperate gamble that failed. The cargo never reached France. The German technology never reached Japan. The gold never paid for the weapons that were meant to turn the tide of the war. Instead, it serves as a permanent ballast for a tomb 3 miles down. The Atlantic Ocean has claimed the I-52, and the extreme depth ensures that the vessel will remain undisturbed. The technology to find it exists, and the ability to visit it has been proven, but the ocean dictates what returns to the surface. The gold stays where it fell. The Atlantic keeps what it takes.